What's up, you data friends? It's Yanis here and welcome to my channel. Today's video is quite exciting as I'm going to show you how to create a custom-based model, both the Python code and the Power BI visuals, in order to estimate when this pandemic is going to finish by country and by state, and what will the numbers look like. I am going to structure this video in the following order. First, I'm going to give you a brief overview of what is the model, how it works, and how you can use it, because I am going to post this model online so you can use it and share your feedback with me so we can improve this. Then I am going to start with the code and show you exactly how everything is calculated. And then I am going to start building this dashboard from scratch and explain how to do it. Right, so the way it works is that first you have to select a country or a state, and I'm going to start with Cyprus, and I'm also going to show some other countries too. Then we have the date it was last refreshed, the number of data points. On the left side, we can see the actual numbers, so things that have actually happened. And on the right side, we can see the estimation of when the confirmed cases are actually going to hit zero, what will be the estimated confirmed cases, the estimated deaths, and the estimated recoveries. Recoveries are not quite correct yet. I'm still working on it, but I'm going to finish this video and then fix it. And over here, we have some very important notes that you have to read and understand before you actually use this model. So the model aim is to give an estimation of when the cases will hit zero per country and state. So I am more concerned about this value than these values over here. This model now takes Hubei's trends, Hubei is the place where all these crazy things started, and applies them in each state. And the reason we do this is because Hubei is the only place that managed to bring the confirmed cases down to zero, assuming we trust those numbers. So we take the rolling averages of Hubei, of increase, of decrease, important dates of when it started, when it peaked, when it finished, and then we apply them in every other state to get an estimation of when the other states and countries are going to finish with this situation. Next, we have our assumptions, which are very, very important. The first one we have is that we assume that other countries and states are going to follow Hubei's trends, which is not the safest assumption to make. We also assume that the current conditions will stay the same, so things like social distancing and contact tracing. Other notes I have is that we have not taken into account the following things in our model. So I'm not factoring in a second wave, the weather conditions, population density, social distancing measures, and vaccine discovery, which are things that can and will impact this model. Next point I have is that estimated recoveries are not calculated correctly, and I'm working on this one. I need to figure out the methodology. And the last point I have is that if you want to fully understand how this model is done, then keep watching the video and we're going to go through the code and the calculations. Right, so down here we have the trends. So just to explain what we see over here, the first line we see, which is this yellow line, is the confirmed daily cases of Cyprus. Then I have all these vertical lines, and just to explain them, the first one is when the thing started, so when the confirmed cases have passed 20. The second vertical line is the current peak. The third vertical line is the estimated date when we are estimating the numbers to peak. And what we have here is that from the gray line all the way to the red line is where we are expecting to keep seeing increases of confirmed cases. After we pass this line and we go down to this line, so this line is the estimated finish based on current peak. So if we assume that Cyprus peak is this one and is not going to have another peak, then we should expect Cyprus to finish, to take the confirmed cases down to zero by this vertical blue line over here, which is the estimated finish based on the estimated peak. And if we want to see the date, is the date down here, the 23rd of May. Moving on, the last vertical line is the estimated finish based on estimated peak. So if Cyprus does peak on this line over here, then we should expect Cyprus cases to go down to 0 on this vertical line over here, which is the 16th of June. Now, the blue dotted line is that if we assume that Cyprus has already peaked, which is over here, and is not going to hit another peak, then is the estimated confirmed cases, so the estimated confirmed cases from current peak to estimated finish. And it's actually the number of cases we're going to see per day is an average until we take the confirmed cases down to 0. The red dotted line now is that if we assume that Cyprus has not peaked yet and is still in the increase zone, then it's going to see on average these many new cases per day until the estimated peak. And after we hit the estimated peak, then we're going to come out of the increase zone and we're going to go into the decrease zone, where we have the estimated confirmed cases from estimated peak to estimated finish. And it's actually the estimation of confirmed cases until Cyprus confirmed cases go down to 0 by the 16th of June. And down here, you can see the cumulative graphs and also all the numbers. In case you do want to sum all these numbers up, you have a summary table down here that has all that data. Right, let's check UK, New York, and Italy maybe before we move into the code. So we change this, United Kingdom. Straight away we see a minus in the prediction and a 0 over here, and this is because the UK did not report any recoveries today. Don't know why, so it's skewing the data. Is messing with the data, it's not skewing the data. And if we come down here, the first thing we see is that the estimated peak bar is on top of the actual peak. So the UK followed exactly the same trend as Hubei did, the model in Hubei. So what we are seeing is that we see exactly the same finish date, which is the estimated finish based on current peak, which is from here until the end, and the estimated finish based on estimated peak. But since the estimated peak is exactly the same with the current peak, we can see that we have the same dates down here. Right, so let's check New York very quickly. So if we come here, we type in New York. First thing we see is that we don't have any data for recoveries, and this is because for the US we only get one total number for recoveries. We don't get it by state. And then if we come down here, we can see that we already have this peak date over here. We are still in the increase zone, and we expect New York to peak on the 16th of April if this is not their current peak. So this is why we only have about 3 days worth of data for estimated confirmed cases until the estimated peak. If the country or the state passes the increase zone, then we are not going to see any of this number, which is the case we had with United Kingdom. And then we can see that we estimate New York to come down to 0 on the 30th of May, assuming this is their peak, or the 7th of June, assuming they hit another peak by this date. Right, scrolling back up again, and then we select Italy. We come down, what we can see is that Italy has actually passed the increase zone and they entered the decrease zone. They only had this peak date over here on the 21st of March. They haven't actually hit a second peak date as we have over here in the estimation. So we should expect their numbers to go down to 0 by the 12th of May. But again, remember, these are estimations assuming the countries and the state follows Hubei's trends. So do not actually use these numbers to take any decisions. These are all assumptions. Right, before we start with the code now, let me just say that if you're new to my channel and you're passionate about data science, then I would really appreciate it if you click the like button, subscribe to my channel, and enable notifications for my future videos. Right, to start with the Python code now, the first thing you have to do is to go into the Johns Hopkins University GitHub repository and download the data. So click on download, and this is actually going to download these 5 Excel files over here. Then you need to open a new Jupyter notebook where we are going to start writing our code. If you are new to all of these, the Python code and the Jupyter notebook, then I'm going to have a link in the description for absolute beginners. For this video, I'm going to assume that your level of Python is intermediate to advanced and not a beginner. Right, so these are the libraries we are going to use. And if you don't have any of these libraries, then you can go to Anaconda prompt, which is this one, and then type in pip install and then the name of the library. Right. The first thing we want to do is to load these 5 raw data files. So after you download them in a location, all you have to do is go to that location. Let me see where I have it over here. 1, 2, 3, 4, 5 files, excluding this one. Then all you have to do is copy this path, then come down to the Python code, paste the path, use // and then at the end add the name of the file, which is the name of the file over here, then .csv, and then this is actually going to read the files into pandas data frames. And then what I'm doing is that I am just investigating the shape of each data frame, how many rows and how many columns. Right, the first thing we want to do is to clean the confirm US data, and this is because when you open the raw data for the US, it's not actually by province and state, it goes down to admin 2. And what we want to do is to sum the data by state so we don't have all this breakdown, and at the same time remove all the columns we don't need. So to do this, I create a list with the exact column names that I want to keep. Then I drop the column names I don't want. Then I use this median for long and lat. And the reason I use the median is because I've tried min and it doesn't work on the map very well. And then median works better. The reason I don't sum and average the data at the same time is because I don't want to sum long and lat, and I don't want to use median for the confirmed cases. So first I use the median, then I sum the values by province and state, and note that I'm using both the confirm and the deaths data sets. Then I am joining together here the sum confirmed cases with the median long and lat, so I have everything in one data set. Then I rename the columns to be exactly the same column names as the global files, so I can join them together. And at the end, I'm reordering the data. So basically we started with the data set looking like this. And now if we first run it and then we check it, just to show you how it is, we can see that we are missing a lot of unneeded columns now. And if you actually check the numbers, they are actually summed for the confirmed cases and using the median for lat and long. Right, moving on, I just checked the shapes again just to see if they are exactly the same as before and I'm not duplicating any data. Then I exclude from the confirm and the deaths from the actual global files the US total numbers, because now I'm not going to use the totals, I'm going to use the numbers by state. And then if you sum the states, you're going to get the total for the US. And the last thing I do over here is that I'm unioning the two files. So I'm unioning the global ones with the US ones, so I have both in one file. And then I'm doing the same for the deaths, so the global with the US. So this is why we had to reorder the columns in the same order now as the global files, so we can perform this union over here. The next step we do now is that we have confirmed deaths and recover in 3 different files. What I want to do is to unpivot them and then join them all together, so I have all the raw data in one file. So I'm using this pd.melt over here to unpivot the data. I want to keep these 4 columns, the province and state, the country and region, and the lat and long. And then I want to unpivot everything else into date. So if we run this quickly, so we run this and we run this, just to show you how the file was before and how it is now. If we check this file before, so copy, paste, and then we do the head, we can see that we have all the dates across columns, but after we run the melt, which is the unpivoting, then we're going to have all the dates into rows and then the values that the dates have into another row over here. The next step now is that I'm converting date to actual daytime, and then what I'm doing is that I'm renaming the value into the actual values of the 3 files. So just because all the 3 files confirm, deaths and recovers have the same value name, I want to actually rename it into confirm in the confirm file, deaths in the deaths file, and then recovered in the recovered file. Then I am checking for null values, and as you can see, province and state has null values. So what I do next is that I'm saying if province and state is null, then I want you to take the value from country and region. And with this way, we are always going to have data in province and state or country and region. Then I check again for null values, and as you can see, we don't have any. Right, moving on, here is where I do the joins, where I'm bringing the 3 files together. So the first join, I say full join over here, but I'm actually using a left join if you see. So first I join the confirm with the deaths, and I'm joining them on province, state, country, region, and date. And then I'm taking the output of this first join and I'm using it to merge it or join it with the recoveries, and I'm using exactly the same joins. And I end up with a data set that looks like this one over here, where I have all 3 confirmed deaths and daily combined together. Moving on, we check for null values in our single data set right now, this full join we have just created. And as you can see, we do have null values in recoveries. However, this is because some countries are not reporting recoveries, so that's fine for now. Then I create a new column, which is this month and year, so it's easier to filter in our front end visualization. Right, the next big step we have is to break the data down by date. And this is because the numbers we have in our full join is actually the cumulative numbers. It's not the daily numbers, the by day. So what we want to do now is to create 3 new columns or fields, which are going to be the daily numbers. To do this, I'm going to use this state over here as an example, just to explain you how the numbers work, and then I'm going to run this on the whole data set. The first thing I do is to save the data into test, then I create a copy of this data, and then in this full join 2, which is the copy, I create 1 new column, which is the date plus 1 day ahead. And then I rename the columns into confirm -1, deaths -1, and then recovers -1. So this new dataset full join 2 is going to look like the dataset we see down here, confirm -1, deaths -1. So it's exactly the same dataset as test. So this is the test down here. The only difference is that it has a new date column, and this date is actually date plus 1. So down here before it was 22. So as you can see, it was 22. Now it's 23. And what I'm going to do now is that I'm going to take this data set and full join it with this data set. However, on the full join, when it comes to date, I'm actually going to join the test date, which is this date over here, the 22nd, with the date -1 of this full join 3. And the date -1, you can see, is 23. So these two are not going to match. They are only going to match when the current date from here is a day behind from full join down here. So after we actually run our full join over here, the final data set, which is full join 3, which is full join 3 down here, is going to look like this, where we actually have the confirmed, the deaths, and the recoveries. These are the cumulative numbers coming from here. And then we have the -1s, which come from here. And the way it joined now is that this number, which is the 22nd, however, when we shift the numbers is the 23rd, it matched with the 23rd over here. So you can see 23rd, 23rd. So what it means is that the date -1 from the 23rd, it was the 22nd. So this one down here moved down here, the 9th moved down here, the 15th moved down here, etc., etc. So on the 23rd, the day before the 23rd, it was the 22nd, and on the 22nd, we only had one confirmed case. And what I do, the last point down here, is that I minus the 9 with the 1, and I get the 8, which is the daily numbers. So if I apply now this code on the whole data set, I'm gonna get the date -1 and the daily numbers for confirms, deaths, and recovers for all states and all countries, which is what I do down here. And then I calculate the daily confirmed, daily deaths, and daily recovers for the whole data set and not just this one state which we have used to give you this example. And the last step I have to get the correct daily numbers is that I come down here and I say when the date is the 22nd, I actually want you to take the cumulative confirmed cases and pass it down to confirmed daily. And this is because our data set starts from the 22nd, so there is no 21st data to match with the 22nd. And I want to take all the numbers from the 22nd cumulative and pass it to the daily as a starting point. And the last thing I do is that I drop all these -1s columns I don't need, and I have just used in order to calculate the confirmed daily numbers. So if we run our dataset right now, just to see how it looks, we can see that we ended up with the dataset having the province state, country and region, land, lot, date, confirmed, and this is the cumulative numbers. Then we have this month here we created before, and then we have the daily numbers. And now our dataset is nice and clean in order to start modeling the data. However, because this video is quite lengthy as it is, I'm going to stop this video here and finish the rest of the video and the tutorial and the code in the next video. Right, so I hope you enjoyed this video and you've gained enough value out of this video. If you feel like you did, please click that like button, subscribe to my channel, and enable notifications for the next video. In the meantime, you can use this dashboard online using the link I'm going to have in the description, and then you can share your feedback in the comments so we can improve this model. Also, if you have any questions, let me know in the comments below. Otherwise, thank you very much for watching this video, and I'm going to see you in the next video.